Hi, my name is Johnson, and now let me continue with the introduction of our project. So, as we know, hydropower plant is one of the renewable energy that is said to be built in Malaysia. This is because Malaysia has many rivers and lakes that is suitable to build dam and generate electricity for the country. So, for the background of the project, it is about an article regarding to Sungai Peting Mini Hydropower Plant has come up with an issue relating to challenges of developing a hydropower plant in Malaysia. One of the challenges is related to the design of hydro turbine. So the problem statement of this project is about the mini hydro turbine design has a problem in overcoming one of the natural events, which is heavy rainfall. Current turbine design could not filter matters such as sand and debris, for example like fish, fallen leaf, and etc. So the objective of this project is to have a solution design for the mini hydropower plant or mini hydro turbine that could filter out sand and debris.
My name is Muhammad Azri, EC-19097, and this is my idea for the mini hydro turbine. So this is my initial drawing and also my initial idea, which is to use a Kaplan turbine. So where Kaplan turbine has two states, which is during a low flow rate, you have the blade in a smaller gap, and also during the high flow rate, you will have a bigger gap between the blades. So as our problem states that the turbine has a problem during a heavy rainfall and also have a problem to filter sand and debris during the heavy rainfall, I was focusing more on the high flow rate design, which is, as we can see here, during the high flow rate, the gap between the blades is more open. And how this Kaplan turbine works, it depends on the guide vanes. So here how the guide vanes will function with the Kaplan turbine, where as we can see here, during the low flow rate, you can see that the guide vanes only open slightly to allow a small flow rate of water to pass, and the shape of the blade will be as shown earlier during the low flow rate, which it has a smaller gap. And during the high flow rate, the guide vanes will open fully and allows all the water to flow, and the blade will also have more pressure on the bottom part of the blade, where the blade will also have a larger gap between them. So on the left side of this drawing, this was my initial idea, which was making a Pico Kaplan turbine, where the design was using a PVC pipe, the Kaplan turbine itself, a net to cover a bigger matter so it can filter better, and also a DC motor. However, my initial idea was too complex for one semester to finish this. For that, I changed the design slightly, and this is currently my idea, which is we remove the guide vanes, and for the turbine, as the problem is more towards a high flow rate, my idea was to have the blade fixed at the high flow rate position, so the gap between the blades will be more open. For that, my idea was to allow the water to flow at a high flow rate constantly towards the turbine. So this is my drawing for the current idea, which is to use an alternator. So for the listing of the materials that we might need, for my current idea was to use a PVC pipe with a 125mm or 150mm diameter, up to 2 or 3 feet height. And also we might need a T-shaped PVC pipe to have as the different holes will cover different parts of the objective, which one is for the water flow and one is for the straight towards the alternator. And for this one we might need a 3-phase alternator. This is my initial idea for this semester. And also we might need a rectifier just in case if we are able to finish it earlier and be able to test the power out. We might need a rectifier to have a DC output, so we can test it on a DC outlet to see if the output really works. So the next material we might need a bearing. We might need to make a bearing bush. Depends on the diameter of the PVC pipe. So the bearing bush will help the shaft, which is 4 or 5 feet we might probably need, to allow the shaft to be able to rotate consistently in the center of the PVC pipe, and also to consistently rotate the alternator. So for the wood plank and a small steel plate, we might need it to hold the alternator and also its wire at a fixed place. And for the turbine, if we are to design it ourselves, we might need a stainless steel at a 1mm thickness. Currently that's the idea, 1mm thickness, and we might need to make 5 of it, as in one of the reference showing how the Kaplan turbine works, or how most normal turbine works, is 5 blade is the optimum number of blades so that the turbine can fully perform. And for the base of the turbine, we might need a blade hub and also a hub. And in case we don't get our alternator, we might have to make a DIY alternator ourselves. And if it's not possible, we might try a DC motor to at least have an output, a DC output. Well, that is all for my idea.
Assalamualaikum and hi, my name is Abdul Bahri, so I'd like to present my idea for our project mini point. So in general, this is my design for my idea. First thing first that I should state in this presentation is the water that came from the river are flowing from this point to this point and separated also to this point. So the water will flow from the high ground to the lower ground with a certain level of height. So in this case, I'm using the slide certificate over here and here to control the flowing water. Why? Because the flowing water rate will change time to time, either high flowing rate or low flowing rate. So if in the low flowing rate, then this vertical door will automatically close, and this door will open bigger so that the water will focus flowing here, since this is the main pipe for our mini water turbine. If the water flow in the high rate flowing, so this gate will fully open, and this gate will open a little bit so that the water will keep flowing in it, and to activate and produce power over here. So this is the slide vertical lift gate, and this is the example of slide vertical lift gate. Basically, this is used in the bigger dam but in this case we're using the smaller one since it is a mini water turbine. So for the next part is here, as I mentioned, the particular gates over here and also the trash rack. So this is the trash rack, the example of the trash rack. So the trash rack I use to as a filtering agent for the filtering part. So it will filter debris, rock, trunk or any obstacle. Basically all of these are obstacles that may enter this part, since all the obstacles can harmful to this turbine over here and will disturb the efficiency of the turbine. So next, let's focus on this part. So as I mentioned, this is the main part for this mini water turbine. So technically this is the design over here. Install the generator over here that connected to the turbine through the shaft. This is the shaft. And it works as a tank over here. Why? The water will fill over here and flow constantly over this tube, in this tube, so that the turbine will rotating or spinning efficiently. Why do I create the tube over here? Because if there is no tube and it will stop here, the water that came out from this tank will disperse, flowing disperse. So it will disturb the efficiency of the spinning turbine. But by adding the tube, the water will flow nicely and rotating the turbine, and the turbine will rotate efficiently. So this is the turbine that I use. There are a few types of turbine, but in this case I'm using the fixed pitch propeller turbine, since the blade fixed so that the water can remain be rotating the turbine. There is some other turbine, for example Francis, Teflon, Screw and others, but for me fixed pitch propeller are more suitable for this design. So next is the listing equipment or stuff that I need to use is the 3-phase alternator that used to convert from mechanical energy to electrical. DC motor, of course, is the turbine, rectifier, trash rack for filtering, bearing bush, shaft to connect between generator and turbine, steel plate as a vertical lift door, wood plank, seat blade, stainless steel as a blade to install as a turbine, blade hub for the blade stainless steel and the hub. So I think that's all for my design idea, and thank you.
Assalamualaikum. So I will be presenting my idea on the water generator turbine. So the idea itself, to solve our problem in my idea is to create a whole mini whirlpool turbine. So in this idea, we will be creating a forebay, which is creating another passage from the river, and for the water from the river will flow into these passages and will be entering this kind of cylindrical hub, and from the water that enter it will be have a whirling movement and down into the turbine, and will be flowing out through the draft tube. So this movement can rotate the turbine that have a shaft that connected to the AC generator. So with this kind of water movement, I have decided to use a Kaplan type turbine, since that's the most suitable design for this kind of water flow. and and in order to prevent the failure on the turbine because of such sediment from the river, we will be using a coating such as a ceramic coating, and we can also consider the material that we use to create the turbine itself. So the most suitable is a stainless steel material, and a sediment such as a small stone, we can increase the gap between the blade of the turbine. So so um, so that's the idea lah. And for this whole whirlpool turbine, whole whirlpool construction will have about a 30 centimeter to 50 centimeter in height, and the diameter of this cylindrical hub is around 30 centimeter. And in the passage for the water flowing, we can also consider a silt measuring device, so we can detect silt that entering these passages. So with this kind of device, we can automatically control another electrical device such as gate. So this is the rough idea for the installation. So from the river, we will be creating a 4-bay beside the river, and by doing that, we can the water will flow into this passage and into this hub, and will rotate the turbine. So as I mentioned earlier, we can also consider a gate on the passage. If something like the silt measurement device detect a high concentration of silt, so the gate will be closed. And for the listing material requirement, so we can make this whole whirlpool using a wood plank and also a PVC material. So we also need an AC generator, so we can use an induction motor as the generator, and we also consider a converter and inverter depending on the load type, whether it's a DC load or AC load. And the shaft that connected to the turbine is a steel type. And for the turbine itself, like I mentioned earlier, it is safe to consider a stainless steel material for the turbine, and we can also make a coating to the turbine using a ceramic liquid. Yeah, so that's my idea. Thank you.
Hi, my name is Vincent, and now I am going to discuss about my idea for this project. So, the idea that I am going to propose is the cross-flow water turbine, which when the water flow from the river, and it will flow into the cross-flow water turbine, which is at here. After flow, the water will spin or will push the blade and cause the shaft. The rotor will be turned, and it will allow the alternator to generate electricity and then send the electricity to the transformer to step up the voltage or the power before it's sent to the electrical distributor. So this is how the cross-flow water turbine works. So basically, there are few important things that need to be considered in designing this water turbine, which is air venting valve, which allow the air inside the turbine to be flow out to avoid any disturbance from spinning the rotor. So the inlet will allow the water to flow into this water turbine, which we want the nozzle or the inlet to be smaller so that more high pressure water will flow into this turbine and rotate the shaft. And yes, this is the distributor, which only allow the water to flow in one direction, and the plates which function to spin the shaft so that it can generate electricity. So the water will enter the water turbine and push this water or the plates, then flow out under the shaft, under the casing. So this is the items or list that needed to design this water turbine, which is a 3-phase alternator, a rectifier, a bearing bush, which around 150 millimeter or 100 to 70 millimeter, a shaft, and a 3D printed casing in trapezoidal shape. So for the turbine, we need at least 20 curved blade stainless, which is made of stainless steel to avoid corrosion, and we need at least 20 curved blades is because we want to allow more water can push the rotor or apply pressure on the rotor so that it is enough force to rotate the DC motor and generate electricity. So for the alternator, the alternative for the alternator, we use DC motor as it is cheap and easy to use. So that's all for me. Thank you.
So after each member have made their own idea and presented to our group, so we have to decide which one of the ideas that we have to choose. So in order to make a decision, we make a decision making by using a few criteria, which include a cost, construction, complexity, practicality, reliability, and filtering ability. And each criteria have their own weighting based and the number and the weighting is decided but when we make our discussion, where the filtering weighting is the highest one among the criteria. So each score for the criteria is made by our group, our each member. So with a score for each criteria is the highest score is 5, and you can see that key in the score numbers, we can see that Azri decision have the highest total score. So that means that Azri ideas is the best in order to proceed with our project. And with the and where and to, in order to make it more detailed, we have to make a problem by using a fishbone diagram on Azri ideas.
So for now, we have chosen our ideas for our next semester IED project, and now this may be our concern for the next semester project construction, where the first one is the environment. As of today, 5th of February, COVID-19 cases has risen to 9,000 cases, and due to that, we may have a limitation of accessible site, or we may have a problem in even finding a test site for our project. And the next one is that for the process of our project construction, in case of we have to do ODL only and we are not able to go back to EMP, we may have a limitation to work in a team, as all of us are living far away from each other, and we may have a problem in even constructing the project itself. And even if we get together, our project turbine may have a change of design, especially the blade, as well, it leads to our next concern is the equipment, on where would we find our stainless steel fabricator machine. And even if we get back to EMP, we might have a limitation to access the equipment lab. And also for the last one is the measurement of our current chosen idea. As for the chosen idea, the design or the measurement may change depending on the test site we have chosen, if we are able to find one. As the measurement of the project design could change the outcome of our project.
So finally, to sum up this presentation and looking forward to the conclusion, we finally managed to choose a design that can be replicated for the next semester using integrated engineering design. So technically, this is our last decision using the plan, and the idea came from Azri. And next part is equipment list. We managed to list up every single thing equipment that we need for this project, and also visual diagram that leads us to the certain problem that we might and will facing for the next semester. So I think that's all from us. Thank you and have a nice day.